No. Welcome to my video tutorial on calculating pH of a buffer solution. You need to be able to calculate the pH of acidic buffers. This can look daunting at first, but is actually quite simple if you go about it step by step. We're dealing with buffers made from weak acids. Remember back when we looked at the acid dissociation constant, Ka, and weak acids? We saw that when dealing with weak acids, which only partially dissociate, we could assume that the hydrogen ion concentration is roughly equivalent to the concentration of the anion. And so we could simplify this to Ka equaling the hydrogen ion concentration squared over Ha. From this we could say that the concentration of the hydrogen ion squared is equal to Ka times by the concentration of the weak acid. So then we could square all of this to find, all of this to find the hydrogen ion concentration, and then find out the pH from negative log to the base 10 of the hydrogen ion concentration. With buffers, this calculation cannot be simplified to this form. This is because the conjugate salt of the weak acid adds extra ions. So these two values are no longer equal, and the acid is hardly ionised at all. For a buffer solution made by mixing a weak acid, Ha, with one of its salts, typically a sodium salt, you can get the following. From this, we can assume that this value is the same as the salt concentration, and then we can say that this value for Ha is the same as the concentration of the unionised acid. If in the question the concentration of the salt and the concentration of the weak acid are equal, then Ka can be equal to the concentration of the hydrogen ion concentration. And that's because A here and Ha would equal the same value. However, life isn't always that easy, of course. But if you know the Ka of a weak acid and the concentration of the weak acid and the concentration of its salt, then all you have to do is substitute the numbers in. So let's calculate the pH of a buffer solution that contains 0.5 moles per decimetre cubed of propanoic acid and 0.1 moles per decimetre cubed of sodium propanoate, where the Ka for propanoic acid was 1.35 times 10 to the minus 5 moles per decimetre cubed. Okay, so step 1, we're going to write the expression for Ka of the weak acid. So Ka is equal to, once we've got this, we can rearrange to make the hydrogen ion concentration the subject. All we have to do now is substitute the values for Ka and the concentrations, and remember that the propanoate ion here is it's fully dissociated, so it's going to be the same concentration as the sodium propanoate in the question, and the propanoic acid here is only slightly dissociated, so it's going to be the same as its initial concentration. So when you pop this into your calculator, you come out as 6.75 times 10 to the minus 6. And that's going to be in moles per decimetre cubed. Now we know the concentration of the hydrogen ion, for step 4 we can calculate pH. And let's not forget that calculation that we've learnt. And when we put those numbers into our calculator, we come out with pH 5.17. Now have a go at these next two calculations. Question 2 gives the masses of the acid and salt, in grams, so you'll have to work out their concentrations. I hope this video tutorial has been useful. Hope to see you next time. Thank you.